Twin snowflakes. A scientist challenges the idea that no two snow crystals are identical. Growing up in Fargo, North Dakota, Kenneth Lebrecht spent a good part of the year surrounded by snowflakes. Flurries could fall there from October to April. Snow was such a common sight. Lebrecht never paid much attention to it when he was younger. Lebrecht is now a physicist at the California Institute of Technology in Pasadena. As an adult, he spends a lot of time thinking about snow, even though it's almost always warm and sunny where he currently lives. Lebrecht is one of the only scientists in the world who studies how snowflakes get their structure. It's a fascinating problem, he says. Had I looked at snowflakes as a kid, I would have seen all these intricate shapes. Everyone knows that no two snowflakes are alike, right? Not so fast, says Lebrecht. In his lab, he grows his own snowflakes in a custom-built cooling chamber. It allows him to control how each snowflake branches and spreads as it forms. Under the right conditions, he can even create identical snowflakes. Let it snow. A snowflake begins its life high in Earth's atmosphere. There, water vapor in the air cools and condenses, changing from gas to the liquid droplets that form clouds. When clouds get cold enough, some of the liquid droplets begin to freeze into ice. During the freezing process, 6 water molecules lock together into a hexagon, or a six-sided shape. This process forms a microscopic ice crystal, a solid whose molecules are arranged into a repeating shape. Next, molecules of water vapor in the surrounding air bump into the newborn snowflake. They latch on, changing directly from a gas into a solid, and join the growing crystal pattern. This process, known as deposition, repeats, and the snowflake expands. It takes anywhere from 15 minutes to an hour for the snowflake to become heavy enough to fall from the cloud. According to Lebrecht's calculations, enough snow forms in the Earth's atmosphere every 10 minutes to make a snowman for every living person on the planet. The vast majority, though, ends up melting before it ever hits the ground. But if the air is cold enough, snowflakes make it to the planet's surface. Lebrecht has traveled to places like Canada, Japan, and Sweden to study freshly fallen flakes firsthand. He catches them on a piece of foam as they drift from the sky. Then he uses a paintbrush to carefully transfer the snowflakes to a glass slide. He quickly puts the slide under a microscope to examine each flake's structure. Snowflakes come in a wide variety of shapes. The most picturesque, says Lebrecht, are stellar dendrites, with their 6 branching arms. Flake pairs. Under controlled conditions, Lebrecht can grow pairs of snowflakes with virtually identical structures. But snowflakes can also form prisms, needles, columns, and 6-sided plates. By studying the shape and size of a snowflake, Lebrecht can determine the conditions under which it formed in the atmosphere. Temperature, for example, has the greatest effect on a snowflake's shape. Humidity, or the amount of moisture in the air, affects how complex a snow crystal will be. 2 of a kind. In the lab, Lebrecht manipulates the same factors that affect snow crystal growth in nature to create his own flakes. He starts by quickly cooling a refrigerated chamber, causing moisture in the air to freeze into billions of glimmering ice crystals. They'll become the seeds for new snowflakes. Inside the chamber, some of the tiny crystals settle onto a chilled glass plate. By adjusting valves on the chamber, Lebrecht can control the temperature and humidity around the plate to coax the crystals to grow into an array of shapes. Using a microscope with a built-in camera, he can view and photograph his creations. Recently, Lebrecht wondered what would happen if he grew 2 snowflakes under the exact same conditions. He found 2 crystals right next to each other on his plate. Then he used the chamber to make sure they would experience the same changes in temperature and humidity. And voila! He ended up with 2 look-alike snowflakes. In nature, these identical twin snowflakes wouldn't happen. It's almost impossible for two crystals to encounter exactly the same conditions as they blow around separately inside a cloud. But Lebrecht is pleased to be able to make them in his lab. It's fun to figure out the recipe for growing the crystals, he says. Science is art. Lebrecht originally started studying snowflakes to get a better understanding of how other types of crystals form. Most solid materials have molecules arranged in a crystalline structure. Knowing how crystals are constructed can help scientists and engineers make everything from stronger cars to more effective medicines. The more Lebrecht studies snowflakes, though, the more he's driven to make new shapes purely as art. His snowflake images have appeared in books, on posters, and in a series of postage stamps. He's also used his vast snowflake knowledge to advise other artists. Before Disney animators started working on the movie Frozen, they asked Lebrecht to show them how to draw snowflakes correctly. Anyone can appreciate snowflakes, says Lebrecht, even if you don't have a fancy lab. All that's needed is a simple magnifying glass. Then, the next time it snows, he says, just go outside and have a look.